Hello everyone, welcome to another video session class. So in today's class we will study about Beckmann rearrangement and Schmidt rearrangement. Okay, Schmidt rearrangement. So Beckmann rearrangement, let us just first study Beckmann rearrangement. So here one oxime will convert it to an amide. Okay, so let us see. So the Beckmann rearrangement is an organic reaction used to convert an oxime to an amide under acidic condition. So here you see acidic condition. So we are using this H2SO4. Okay, that is acidic condition. So first step, this is not the step where Beckmann rearrangement is used. From this step to conversion to this step, this is known as Beckmann rearrangement. So first, for example, here this is carbonyl group. So that carbonyl group we treat with hydroxylamine, okay, hydroxylamine NH2OH, and that will convert the cyclohexanone to cyclohexane oxime. So oxime group C double bond N OH. Okay, so that will undergo Beckmann rearrangement in the presence of acid. For example, H2SO4, so it will convert to CONH, C double bond ONH, that is amide. Okay, C double bond NOH, that is your oxime, and from that one C double bond ONH, that is amide. Okay, under acidic condition. So another reaction we can say this one are, so C double bond, this is cyclic, here it is not cyclic, C double bond NOH, that is oxime. You treat with H2SO4 concentrated, heat it, so under acidic condition it will convert to C double bond ONH, that is amide. Okay, so an acid induced rearrangement of oxime to give amide, so that reaction is known as Beckmann rearrangement reaction. So reaction mechanism, so oxime generally have a high barrier to inversion, so oxime don't invert themselves very easily, and accordingly this reaction is envisioned to proceed by protonation of the oxime hydroxyl will protonated, see this step, followed by migration of the alkyl substituent trans to nitrogen, so that after that one alkyl substituent R will migrate to N. Okay, so in trans position, the nitrogen oxygen bond is simultaneously clipped or breaked with the expulsion of water, so one molecule of water will come out to break this nitrogen oxygen bond. Okay, clipped with the expulsion of water, so that formation of free nitrogen is avoided. Okay, so that will avoid the formation of free nitrogen. So here you see this is the reaction, acid catalyzed H2SO4, so R C double bond NOH. So in this step you see R C double bond NOH, that is oxime, so this is oxime NOH. So proton will, from acid proton will act, so it will attach to this one, this nitrogen will migrate to this alkyl group will migrate to nitrogen, and this bond will break down. Okay, so as a result OH then H, that is H2O will come out, and we are getting R2C double bond and R1. Okay, that means this R1 migrated to nitrogen, so it will undergo a change R2C. So this that means this electron pair will be taken by the nitrogen N positive, and the carbon will become C positive. Okay, so R2C and R1. Then this water will attack this carbocation. So you see water attack this carbocation. So OH. Okay, OHH. There is water. Again this H will come out, okay, as a proton. So we have added one proton here, so it will come out, so it will form R2C and R. That will undergo some isomerization of the structure, there is changing of the position of the group. For example, here H will, this proton or H hydrogen will migrate to nitrogen. See, this hydrogen is migrating to nitrogen, so ultimately it will give the C double bond ONH, that means amide, from oxime to amide. Okay, so applications of Beckmann rearrangement of benzophenone oxime. So here you see benzophenone oxime, you use acetic acid, okay, in acidic HCl, so it will form benzanilide. Okay, NHCO, that means CONH amide, from oxime end up C double bond NOH to amide. The next Beckmann rearrangement for cyclohexanone oxime. So So you see this is cyclohexane on oxime that will undergo, it is the first reaction we have seen in the beginning part of this video. So it will, caprolactam will form. Then next, in the synthesis of caprolactam also, this is just the repetition of that reaction, okay, which is used in the production of nylon. So the caprolactam is precursor for production of nylon 6 for the synthesis of paracetamol by converting a ketone to a ketoxime with the help of hydroxylamine. So in the synthesis of paracetamol, there is antipyretic drug. This reaction is also used in the synthesis of various steroids and drugs in the production of some of the chlorobicyclic lactams. So those lactams are prepared by this. For example, this is lactam, okay, C double bond O NH. So those lactams are synthesized or produced by this reaction. So next, let us see some important functional groups which are used in this reaction, that is Beckmann rearrangement and Schmidt rearrangement. So this is imine, okay, C double bond N, it is imine. Then this is azide, okay, N3, okay, N3 minus, that is azide anion. Then this is enamine, okay, why it is enamine? Amine is there, N, then En for double bond, okay, double bond, enamine. Then next, oxime. So two type of oxime, aldoxime and ketoxime. Why it is aldoxime? Because of RCOH, okay, because of presence of H, because RC double bond OH is aldehyde, okay. So from aldehyde this oxime is derived, so it is known as aldoxime. And here you see RC double bond OR, there is ketone, from ketone this oxime is derived, so it is known as ketoxime. So next, let us start the Schmidt rearrangement. So Schmidt rearrangement is an organic reaction in which an azide react with a carbonyl group to give an amine or amide with expulsion of nitrogen. So one nitrogen will expel from this azide, this is azide, okay, N3H, okay, from the nitrogen, and as a result one carbonyl group will give an either amine or amide. So you see this is R C double bond OOH, this is carbonyl group C double bond OH. So in presence of acid, and this azide, okay, azide N3H. So you see N3H, okay, this is same, this structure and this structure is same, so it will give RNH2, that is amine. Next, these two reactions are same, correct? These two reactions are same. Next, this is aldehyde. So it is also having one carbonyl group. So N3H, that means azide, in presence of acid, it will give RCN, that is nitrile, and or cyanide group, or this is CONH, that is amide. So here I have written it may either give amine or amide. So here it is giving amide, okay, CONH. Then you take this example of ketone. So it is also having one carbonyl group C double bond O group. So in presence of N3H, that is azide and H2SO4 acidic condition, so it will also give C double bond O NH, that means amide. So this is the reaction known as Schmidt rearrangement. So let us see the mechanism. So mechanism, I will give two mechanisms. You just see these are same in terms of acid, okay. So it is also containing one carbonyl group, that is C double bond OH. So this is reaction we have already seen. So you see here R C double bond OH acid. So one proton will attack to this oxygen to give HOH. So ultimately that HOH will come out as a water. Next, what will happen? So this carbon will acquire one positive charge, okay. So that will be attacked by the electron present in azide, okay. So that electron, bond pair electron, will attack this this carbon, positive carbon or cation. So ultimately this nitrogen will attach to this carbon. So NH N, okay. So you are getting NC bond, okay, NC bond. So next, what will happen? This bond will break and N2 negative will come out, N2 minus will, so N2 will come out, okay, not N2 negative. Nitrogen gas will come out. In the next reaction, what will happen? Water will attack this carbon, that is this carbon, okay. So here in this reaction, you remember again the migration of alkyl group, that is R, is taking from carbon to nitrogen. So earlier you see RC, but here it is RN, that is migration of alkyl group R from carbon to nitrogen. So after that one, water will attack this carbon C double bond O, so it will form C double bond O OH. Okay, that means OH will attack this carbon. So after that one H plus will come out from this one. Okay, from this H will come out. Okay, this H will come out as a proton, so H plus, so you see C double bond O negative. So next what will happen, this will give its lone pair of electrons to this bond, so it will break down, so ultimately CO2 will come out. Okay, CO2, okay, carbon dioxide will come out, and this bond will break down to give RNH2, that is one amine. So from acid to amine, okay, in presence of azide and acidic condition. Next another, so this is here we have seen the precursor as a, or starting material as a acid, carboxylic acid, but next this is ketone. So same reaction we are getting the amide. Okay, C double bond O NH, correct. So you see this is again this hydrogen will H plus will attack, so it will form OH. Okay, COH. So next what will happen, this nitrogen, again same mechanism, this nitrogen will form a bond here, so ultimately you see COH, then NH, N double bonds. Next again what will happen, one water molecule will come out. Okay, so from this OH and H, water molecule will come out to form RR. So you see RR dash, C double bond N, then N triple bond N. So again this bond will break. Okay, this bond will break, and this alkyl group will migrate to nitrogen, from carbon to nitrogen. So N2 will come out, and here you see RN double bond Cr. Okay, next again water molecule will attack, the same mechanism. So you see here water molecule attacks, then again one proton will come out from this oxygen, so you see OH is there. Next what will happen, this H will come out to give C double bond O. Okay, this H will leave from here, and as a result this will form C double bond O. Okay, C double bond O. So this H will form the bond here. Okay, H will come out and it will form bond to nitrogen, NH. Okay, so ultimately we are getting R C double bond O NH R. That means one amide, from ketone to amide. Okay, so this is the mechanism. Next, what is happening? Applications of this Schmidt reaction. So Schmidt reaction is used in the preparation of primary amines. So you see para-toluic acid NH3. So it will be N3H. Okay, so it will form para-toluidine. So next, phenylacetic acid. So here it is given NH3, it should be N3H. Okay, likewise this one N3H. So ultimately here it is benzyl amine. So N2 and CO2 will come out. Then Schmidt reaction is used in the preparation of alpha amino acid. So here you see this is the product, alpha amino acid. Okay, alpha amino acid. So we are getting the product. So here in this step our Schmidt reaction is utilized. Okay, so that is the thing. So here you see COC2H5. So CO, from CO it is CONH. It is from carbonyl group, amide is produced. Okay, the next Schmidt reaction is used in the preparation of lactones, cyclic ketones. When undergo Schmidt reaction give lactones. So cyclohexanone, okay, that is cyclic ketone. When again this is not NH3. Okay, in the I have taken from the book. So it is N3H in presence of acid, it will give caprolactam. Okay, which is a precursor of nylon 6. So this is all about these two reactions. So I hope you have understood. Thank you.